continue with the presentation from Vratil. Daniel is a software engineer at Vratil, where he currently works on Sandboxing. He's going to explain us what this thing about Sandboxing is and why it is important, and what the KDE and Qt applications need to make it work. So, thank you, Daniel, for the presentation.
Thank you. So, hello, I'm Daniel Vratil, and I want to present you something I've been working on at Red Hat for the past couple months, on and off. We got interested in sandboxing because it's cool and it's what all the cool kids do, so we started doing it as well. And this specifically, there are many sandboxing applications and ways to sandbox applications. This talk is specifically about the one we are working on, which is called XDG app. So I want to explain how it kind of works and what it is good for, especially how KDE can benefit from that. So just to make sure that we are all on the same wave, I want to kind of explain what sandboxing means in the context of this presentation. So to me, sandboxes should be isolated, controlled, and reproducible. Isolated means that the application that is running inside the sandbox should well, it feels like it's alone on the system. It doesn't see any other processes. It doesn't have access to any system resources, cannot talk to dbus, cannot talk to network, cannot see the host file system, and so on and so on. So this is obviously for safety reasons, mostly. It should be controlled. So controlled means that the application doesn't choose on its own to just be sandboxed. That doesn't make much sense. There has to be another application, like XDG app, which actually sets up the sandbox and then runs the application inside the sandbox. And it also controls what things the application can talk to. So restricting the application the way I just mentioned, that doesn't make much sense. The application wouldn't do nothing. So if there is an entity that controls the sandbox from the outside, it can say, okay, this application can talk to network, or it can access the host file system, and so on. And finally, it should be reproducible, which means if the application terminates and we clean up the sandbox, then when you try to run the application again, we can set up exactly the same sandbox as before, so that the application doesn't notice that we actually destroyed it and built it from scratch again. There is an exception, kinda. The reproducibility usually means that whatever data the application writes are lost. In case of XDG app, we actually persist some of the data, user configuration, stuff in the XDG config and the XDG data drs. So, with that done, the XDG app sandbox specifically is a cross-desktop project, which means that we want the bundled applications to be bundled once and then be possible to run on any system. It doesn't matter which distribution it is. So for that reason, we need to somehow solve the problem with binary compatibility, missing libraries, and this stuff changing between each distribution. And for that reason, we have something called runtimes, and then we run the application bundles on top of these runtimes. So the runtime, in the sense of XDG app, is a well-defined file system environment. File system environment is, well, that's weird, means that basically the runtime just contains file system tree, basically. It's just libraries, utilities, and files. The well-defined means that it is exactly set, or it is defined what the sandbox, what the runtime will contain. So if I say we can have Qt runtime, then I say, well, the Qt runtime contains the base system and Qt, and nothing else. And you cannot add things into it just because you want. If you want KDE frameworks, you create KF5 runtime, which will have the base system, Qt, and KF5 libraries. It is important to mention that the runtime is frozen to changes, which means if you create a runtime with KDE frameworks 5.10 and then KDE frameworks 5.11 are released, you don't update the frameworks in the runtime. You create a new runtime, just with different version in the name. So this is important. The runtimes never change. With maybe with the exceptions of, let's say, critical bug fixes or security fixes, but it's not like we just can take stuff and update the entire stack or update random libraries that are part of the runtime. I mentioned that we use some base as a base layer, the system libraries that are available basically on every distribution or that basically make the system. Currently we use the Yocto base. Yocto is a project from, I think, Free Software Foundation. The idea is that they define some set of libraries and versions that kind of work together, and it is aimed mostly for embedded developers so that they know what is the stable base for their embedded Linux systems. So we use it as well because it's cool. If you maintain a runtime, you don't want to take care of all the system libraries. So the Yocto upstream takes care of that, and we just pull it in and build it. Here are some examples of the names I use. So we use the reverse URL format /architecture / the version of the runtime basically, and there is a platform and SDK difference. So when we create a runtime, we create a platform, which is just a type of runtime, let's say, which contains the libraries and the utilities only that are necessary for application to run against it. The SDK contains the same as platform, but it also contains development headers, compilers, debuggers, and all the stuff you need to actually build the application against the runtime and to debug it if necessary. Yeah, the user overlay means that basically the runtime can, well, disregard it. We don't have time for that, I guess, to explain in detail. Anyway, one last thing I want to mention is that we use OS3 to store the runtimes or the application bundles. OS3 basically is like a Git for file systems. So you can commit the entire file system trees into there, and then if you do changes, you just commit them again, and it can show you diff between revisions. There you see which files changed. It doesn't actually, it cannot tell you what changed in the files, but it just tells you these files changed between the revisions, which is also cool because that way we can store all the different versions of the same runtime in the same OS3 repository by using basically branches. And then if you have one application that requires Qt 5.4, another application which requires Qt 5.5, we simply do checkout of different branches into each sandboxes, and you can run these things at the same time. So this solves the problem with different applications requiring different versions of the same stuff, or you can even run two applications in different versions of the same application at the same time, because the sandbox isolates it, and the storage allows us to do that. Now to the applications. So application bundle is basically we just take the application, we build it against the runtime that it needs. So let's say if I choose Qt, so I know that Qt needs only Qt frameworks and maybe some other system libraries. So I know this is provided by the KF5 runtime. So I just can build Qt against the KF5 SDK, and then the bundle will only contain the Qt binaries, the library, and the data in user share. Sometimes it can happen that not all dependencies are available in the runtime. The runtimes are static, as I mentioned, so we don't allow merging two runtimes together to satisfy dependencies of applications. So unfortunately, it is necessary for the application to bundle the dependencies that are not available in the runtime into the application bundle. So for instance, for KDE games, I bundled a couple of KDE games applications. So the lib KDE games, or whatever it's called, is not a framework. So it's not in the KF5 runtime. So these bundles contain not just the game itself, but also the library that they need. So yeah, as I mentioned, it runs again the specified runtime. So the application simply said in its metadata, I need this runtime of this version, and the XDG app just takes care of it. The application in the repository is in or when you create this the sandbox, and set up the file system from the runtime, then a special /app directory is created, and the application bundle is mounted into there. And we also export the necessary variables. So path is first in app, then fall back to bin, LD library path, Qt plugins, and all these libraries. All these variables are first pointed to the application folder. So in theory, application could even override some plugins from Qt or KF5, and then we fall back to whatever the runtime provides. Now, so we have runtimes, we have applications. Now, how to put it together? Well, we use the XDG app tool, which was originally written by Alex Larsson, a colleague of mine at Red Hat. He still maintains it. Currently, it's a free desktop project, so it lives on freedesktop.org. The wiki, unfortunately, is still on GNOME wiki page, but hopefully we move it at some point. I already said it's a cross-desktop tool, so basically you can run the bundles and the runtimes on every distribution you want. The only necessary thing that the distribution must provide is the XDG app tool, so that we can set up the sandbox. So this is all it does. Basically, it does the single XDG app tool does everything that you need to create, set up, and run sandboxes. So you can create, add and remove the remote OS repositories. So basically, like git remote add remove. You can install, update, and remove runtimes and repositories. So runtimes and application bundles. So you just that's sort of a git checkout. So you just say the name of the remote and the name of the branch you want to check out, and it does a local clone from the remote repository. And once you do that, you can run it. It can also allow to create the application bundles. So it prepares the runtime that you need to have to build the application bundle. Then it change routes into it and calls whatever command you give it to actually build the stuff. And then it creates the bundle, exports metadata. We do some other magic, like certain files are exported, so they can actually be mounted outside the sandbox, like desktop files. You want basically those files to be somehow exported to your host, so that you can see them in KRunner, for instance, and then they just don't contain the simple binary name, but it says XDG something. And yeah, finally, it actually setups and controls the sandboxes and what the application in the sandbox can or cannot do. The way it works, more or less, is that it creates the change route. The change route can be empty, or we can mount the actual user file system into it. That depends on what the application metadata actually require. So the application metadata, the bundle metadata say that what if the application needs just the entire host file system, or just uses home, or whatever else. Then we mount bind the runtime tree. So we find the right runtime, you do the OS tree checkout, and mount it into the root. If you don't have the access to the host file system, then basically the runtime tree is the entire file system that the application will see and have. If the application bundle actually requires access to the host file system and it is somehow approved by the XDG app, then the change root contains the actual root of the host system, and the runtime file system tree is mounted over it. So we hide the original user from the host, we hide the bin folder from the host, but for instance the /opt or I don't know what else that you can have on your file system, it will be visible to the application and you can access it. Then it mounts the application into the /app folder, and when this is done, it uses all these awesome weird things that the kernel provides us with and other security tools. So we do PID namespaces, it creates a C group, it creates its own debug session. Hopefully when you have KDBus, this will be much easier, but still. And some Linux contexts and whatnot to make it kind of secure, and then it runs the application. So, demo time! So, I already, you can see. Yep. So I've already, I've created a repository where I've got some runtimes. I have a Qt 451. I have an ancient KF5 5.9 because that's when I did it and couldn't be bothered to make a newer version. And I've bundled a couple applications. So let's say, right, so I can just try to add a new remote. It's done. I can now try to add a new remote, which I will just say xdg app, add remote, the name, and some remote URL. I won't do it, I already did that. I can list remotes, so, user. So I have already a remote called KDE and local. Local is my local clone, KDE is something I synced to my server, but it takes forever, so I use the local clone. So, oh yeah, and there's the user switch, because xdg app actually supports for remotes, runtimes, and applications. It supports user, system-wide deployment. So then you need root privileges, and it's stored in system-wide folders /var or somewhere. If you use this user switch, then it's per user. It's stored somewhere in .config, .local share, and each user can manage their own. So I have this in my user. So now I can look what is available in the how's it called? List runtimes that are installed locally, or I could just install runtime as a user from the local remote repository, and I would want to install, let's say, KF5 platform, the version 5.90. This would be basically sort of OS3 pool, so like git pull from the remote repository. I won't do it, it takes forever. I already had it locally installed, as we saw before. So now I can look what applications we have. Oops. Oh, it's this apps. So I have lots of applications installed. Some of them are ancient and don't work. Some of them are new but still don't work. So again, I could just install it remotely. So app, install app as a user from the local clone, and it's called, let's say, org KDE marble. I think I need to, oh, it's already installed. However, I just finished compiling a new version of Marble, so I can do update app user org KDE marble, and it will just download the new version that I just compiled and pushed into the repository and install it into my local clone. Now that it's done, I will check if I forgot something. Nope. So I can do xdg app run org KDE marble. I will move my mouse here so it appears here. And after some time, yeah, it's here. We get marble. So this is actually running a sandbox. I allow this access to DRI, so this is accelerated if it's using acceleration. You can tell by that it's running in Sandbox because it's using the default configuration of looks and everything. I can do open. I cannot talk to Kio yet, I think. Yeah. Boo. So yeah, so basically now the application is running on its own in a sandbox. How to prove it? Well, I can. Oh, sorry. I can do xdg app run. xdg app run command bash org KDE marble, which basically sets up the sandbox and everything. It just runs bash instead of marble. So now I'm in the sandbox. I can look at the root. This is the root of the sandbox. You can see the /app, and there's lots of stuff missing. If I leave the sandbox and show you my real root, you can see there are more folders. So this application actually doesn't need access to the entire file system. So I only said it needs access to home. So if I go back to the sandbox and actually go home, it doesn't show anything. Why? Maybe the metadata are different, so we can check. It's not here. Let me check it. Well, doesn't matter. Let's not waste time. So this is how it kind of sort of works sometimes. Can I get the presentation back, please? So it's quite easy. You have a single tool to control everything, and just in the perfect world, and in the future, hopefully we will automate this or integrate it with some package manager or whatever, so people don't actually have to learn how to use XDG app. They will not need to actually know that you need this kind of runtime for this application. Right now, this is not solved. If you install an application but don't have the runtime it requires, it just says meh and quits. So, but this all can be automated. The metadata are available, so we can just browse they can be indexed, browse, and whatnot. Now, I guess I should say what this is actually good for, since I've been talking about it for like 20 minutes now, and I don't see my notes again here. So obviously, you can secure it on third-party applications. Nobody trusts Flash. You don't trust Spotify because you don't see what the applications do inside. So putting them into a sandbox is pretty cool, right? For instance, for Spotify, Spotify doesn't need to see your root, doesn't need to see your home, so all your files are safe. But because we persist the cache directories and the config directories of the application, it will still remember all the settings you set there. It still remembers. It will still have all the tracks cached locally. So for you as a user, it won't be any difference from the user experience point of view. But from the security point of view, it's much better than just running it on your computer. The second point is reproducible environments for the devs. Obviously, that's something we want. If a user reports you a crash, then you get your backtrace, then you need to reply, okay, could you tell me what versions of all these packages you have installed? They don't reply, and then you just close it, right? So with runtimes, you can either see it in the backtrace, or you can just ask, okay, tell me what version of this application you have. That's all you know. Just what version of the application you were running, because from there you can check what runtime it had, and then you can clone it locally, get into the sandbox like I did, just use SDK instead of platform, suddenly have GTB there and debug symbols, and you can reproduce the crash on the exactly same environment that the user did, right? Because the binary environment is completely the same, it's exactly the same. So this is something that for developers would be really useful. The third point, direct upstream to user upstream, is that we can get rid of the packagers people. And basically, upstreams can provide their binaries of their applications, and then they can ship them directly to users. So, and unlike the need for packages today, it's just because each distribution is different, so you need to compile it again and again for each distribution. Since the runtimes are the same everywhere, you don't have the problem, so you can run the same binary that upstream builds against the runtime on any single computer. Sorry. Which also basically is the fourth point, distribution independent binaries. Now, what are benefits for... oops, what? Oh, okay, whatever. So, what are benefits to KDE? So, better adoption of frameworks by third-party developers. Right now, frameworks have monthly releases, right? So the enterprise people, I don't know, they say like, oh, this has monthly release. This is not definitely enterprise ready, right? If it's enterprise ready, they don't have release for past couple of years. So, but if you give them a runtime, where you say, well, you can develop your application against frameworks 5.9, and then you can get it everywhere on every system, and then they can do it. They don't need to care that, well, if we now do our proprietary application, it will stop working after they update to frameworks 5.10, right? You can say, not a problem. You can just say you depend on runtime with frameworks 5.9, and you are happy until the end of the world. You just need someone to, backport the security fixes, but that's easy. That's really easy. Same environment for users and developers, I already mentioned that. It's easier to reproduce bugs. That's something we would really like to see in KDE, right? For us as KDE, developer pushes a fix to Git, triggers the CI build, we already have that. It does, cover the scans and whatnot. It could just also build a bundle, right, of this snapshot, and it could publish it to some repository, and the user could just immediately pull it and test whether the bug is fixed. So, and wouldn't have to wait for distributions to maybe pick up the patch and backport it to the version they now have, or maybe update the application to the next release, which will happen in half a year time, right? Well, and finally, wider beta testing. Right now, KDE relies on a couple major distributions to actually have the manpower to package beta releases And then we rely on a couple of users being actually willing to update their runtime system or the entire KDE to this beta release. And that means we don't get as much beta testing as we would maybe want to have. So if KDE just publishes beta binaries, application bundles of beta versions of the KDE stack, then people can easily just get Qt, the beta version of Qt, and test it and see if the bug was fixed and report or regressions they found. And they don't need to update the rest. They don't need to update KML because they depend on it for their work, but they can afford updating Qt. And if they find out that Qt crashes for them all the time, well, they just revert back to the older version without touching the rest of the system. So I think this is really useful. We should totally have it. I just a lot of work to do it right now, and there are many problems with KDE. I don't really have time to go all into the details how we do it on the lower levels. That's why I have both tomorrow on Wednesday morning. So if you want to look into all the hacks we need to have to make some KDE applications work, and that still don't work. So to get, for instance, Kio is broken right now, and some other stuff. I can also show you some in-depth stuff, how it actually creates sandboxes and runtimes and applications. If you want to know some how it works, what the designs and what the plans in the future are, this is listed on the wiki page. We have a mailing list for the XDG app tool. We have also an IRC channel, so you can talk to us there, or you can mail me on my work or KDE email. And that's all. If you have any questions.
How are updates handled?
Yes.
How are updates handled? Like, if Qt gets updated, how does it get distributed into all the users?
When you create runtimes are never updated. I mentioned that earlier. So if a new version of Qt is released, you create a new runtime with that new version. And then the application developer can decide whether he wants to use the new version of Qt and just updates the metadata of that application and release the new version.
I have three questions. What about security updates? So if there is some bug in OpenSSL, you still continue to use a bug in OpenSSL?
No, that's the exception I mentioned, that you can do you can change the necessary fixes. You can update the runtimes, it's not impossible. You just rebuild the runtime, push it into the OS repository, and then users need to do the pull, right? But the idea is that the major versions of the libraries don't change. That you have Qt 5.4.1 runtime, and that will always contain Qt 5.4.1 forever. And you may do minor updates, like backward security fixes into the libraries, but that's all you do.
Okay, another question. Is the application running with the same user ID of the user?
Yeah.
Oh, okay.
Yeah.
And one last question. How do we think to handle the problem with the configuration? If I load custom application, I will not allow the application to access my own. At the same time, I would like, for example, to have my accessibility settings turned on.
Right. We don't handle that right now, but the plan is, I already wrote a simple tool that does sort of dbus proxy. So the plan is that this tool would also, on the first run, it would copy some configuration files from your real home into the Sandbox home. So KDE globals and this basic configs would be copied over, so that you can get the same looks and same accessibility.
Well, here I see another problem. Is this action going to be performed by root user?
No.
Okay. Because
the XDG app is running under your user. You don't need root privileges or any of this. Basically, for the most complicated part, we just use some systemd stuff.
Okay, because I'm a bit scared about some possible implications with NFS version 4 that a root user cannot access user's files.
Right, but that's I don't know if this is what NFS security problems are something that XDG is not supposed to solve.
Priorities. My question is kind of related to what he said. if you run one version, for example, one version of Qt and one runtime, and there's a new release, you would like all your configs or your settings to be migrated to the new runtime. And by that, you would need a persistent storage somewhere which you would bind from your actual home. So that means you have to give it to the rights to edit a folder somewhere in your home.
Not necessarily. It doesn't matter if you use the real home or the fake home. We always override the xdg config directory, which is where the application store configuration files and data. And we point them to /var/something. And before the sandbox is destroyed, we take this data and persist them on the actual home. So you actually have your configuration persisted. And if you just update, so this OS3 do this git pull, basically, on the application bundle, so you get newer version, then if you update the current, well, for applications, for instance, we only have one branch. We keep, I call it master, so I keep updating that, new versions and whatnot. So then you would just get a new version and run it. The same, basically same sandboxing, runtime, same configuration, everything. If you would have a new version of the application in different branch, like we do with runtimes, then this is a problem. We don't have a migration solved for this yet. Basically, we would need to save the data from the old version configuration directory and copy it to the new one. It's not solved yet, but we can talk about that both.
Yeah, I suppose you have some more for display server does with you and that kind of thing, but I was wondering how are you going to deal with joint rendering like for games of GL, which you need at the same time access to some device nodes and also some user space driver of the GL driver, which might be quite voluminous and also depending on the vendor of the user running it.
Right.
You have different drivers for different.
Yeah, for this we basically, the runtimes can have extension points for certain things. They have extension points for GL, extension points for localization. And if the application says that it needs DRI, then the XDG app tool actually mounts this library, the DRI libraries and whatnot from the host system into the sandbox. For dbus, it's complicated right now. We want to use KDBus, right, to control what stuff can talk to. For now, we have a very slow glib daemon that just proxies. Too many questions? Yeah.
Yeah, I have a question about the XDG apps process. How do we suggest new permissions?
Well, you like the permissions that the XDG app doesn't know yet, or
Yes.
Talk to upstream. Basically, each application bundle has a metadata file where you list a list of privileges it needs, which are defined by the XDG app.
Yes, but some that don't exist yet.
You have to talk to upstream to basically support this in the XDG app.
I don't understand what you mean by upstream.
The XDG app developers, right? We need to add these new values into the application so that you can parse metadata and set up the needed stuff correctly in the sandbox.
And how do I speak to them?
Talk to me or talk to us. Well, we have a XDG-app IRC channel. We have XDG-app at lists3desktop.org mailing list. So talk to us there, or you can send mail to me, or just talk to me here. Sorry, out.
I have one last question.
Yeah.
Yes, what about sharing files between applications? If you start sandboxing everything, you have to somehow communicate with programs like from Krita to WebView and so on.
Well, then you need to allow this application to basically see your user home, to host the home from the host system, right? So then it can write to the other applications folders. But basically, yeah, we don't have proper file sharing between applications, so that's another thing that breaks in KDE right now. So yeah, not there.
Okay, thank you very much for the presentation.
Thank you.
So,